Hello everybody, my name is Saiharsh, and as you can see, I have made a hand washing project that basically explains the importance of washing hands to kids. Okay, so we all know that or like at least we've heard that whenever we wash our hands for like with soap, basically any virus that's there can get killed, especially the COVID-19 virus that we're in right now. So basically, so how does it destroy the COVID-19 virus? I mean, it's not some type of magic, right? So basically, the way it does it is that soap particles, or basically soap is made of these tiny little particles. Basically, there are two parts: a head, then a tail. So basically, the tail, is you may see something like really thin and really long. After a head is like some type of a ball, like this for imagination. So basically this head is very hydrophilic, which means that it wants to stay close to the water. And then the tail is very hydrophobic, which means that it wants to push the water away, or that it wants to get away from the water. So basically, but then one more interesting property is that basically the tail wants to get close to fats and proteins, while the head wants to repel the fats and proteins away from it. So basically, so basically the COVID-19 outer membrane. So basically, there's two layers. It's a bilayer virus, and basically both of the layers are made up of proteins and fats. So you could think of it that the soap particles will attach to the outer membrane of the virus and will pull it apart. And basically, the reason being is that the tail will want to stick close to the virus's protein membrane. But then it wants to push away the water, and then the head wants to push the virus's membrane away. But then if both of them are connected, then basically both of them are going to be pushing in opposite directions, right? So basically, you could think of this is the coronavirus. Then you know that this finger is my tail, and then this finger is my head. So both of them pushing in opposite directions, which is essentially going to make so much force on the COVID-19 virus that it's going to break part of the outer membrane. So basically, there will be multiple of those small particles basically surrounding the whole virus itself. So basically, with that much force, both of the layers of the COVID-19 virus will just be destroyed. So that is why it is recommended to wash your hands with soap for at least 20 seconds, because I believe that's the minimum time, or like that's the best time given to the soap to destroy the virus. So basically, when I explain this to you, you will understand. But then think about my 2-year-old brother. He doesn't understand because he's still very small. So basically, take time to explain it to him. And as a matter of fact, I did try to, but he just doesn't understand the use of standing in one place under running water for 20 seconds in different ways of washing your hands. It just doesn't make sense to him. And basically, that is why I built this machine. As you can see, it basically activates and it plays a sort of tune for basically 20 seconds. Let me see, for the moment that you're washing your hand, it will play a tune for 20 seconds. So that is the basically that is the machine that I built. So basically, next up is how the circuitry works. So let's get into that. So as you can see, I've opened up the circuit over here. So basically, basically the way this machine activates, basically, how does it know that you've started washing your hands? Well, I have a tiny little photoresistor over here. As soon as I move my hands, or basically get close to the photoresistor, you can see that it has activated right now. So basically, you can hear it's playing a tune. So basically, this tune will go on for 20 seconds, which means that this is the time that you have to keep on washing for. And basically, I put this tune so that basically the kids will enjoy it, and it's a really kind of funky type of tune that's kind of funny as well. So basically, after the 20 seconds, you've seen that the light has turned off, the red light has turned off, and basically that means that your time is done. So as soon as you get your hands close to the photoresistor like that, you'll see that the red light is turned on right now, which means that this is the time that you should be washing your hands until it's done. So, you know, I'll just be washing my hands over here for the 20 seconds until the tune is done. So basically, after the tune is done, you will see that the green light over here will activate after the tune has been done playing. So as you can see, it has activated. So basically, these are just two random LEDs. One of them is a red LED, the one that kind of indicates that you're supposed to be washing your hands, and basically the green one that says, okay, you're good to go, you're washing it for enough time. So basically, I also have a piezo buzzer here, which is a type of buzzer that is activated with current that is kind of basically the pulse kind of keeps on going up and down like a wave, and basically that is how it's activated. So basically at the heart of all of this is this kind of big chip that you see over here. That basically that's an Arduino Wemos D1R1. So basically, like it's basically it's very functional and pretty cheap, so you can just buy it off Amazon. So basically, let me go ahead and explain each of the parts. The first part, as you can see, is are these LEDs. Now I'm sure basically we've learned all about LEDs in our classes, but basically behind it, if you look a little bit more closely, you'll see this kind of weird thing sticking out. Basically, that's called a current limiting resistor, which means that usually LEDs can only withstand a certain amount of current. But then, like what these current limiting resistors do is that they kind of limit the flow of the current because like the Arduino is sending out a very high voltage of current with which the LED cannot handle. So basically the resistor resists some of the current and kind of holds it back and doesn't let too much of it flow into the LED and burst it. And basically you can see that I have two of them. One is right over here and the other one is right over there, and basically they're connected to the LEDs. After that, the second part is the buzzer. So basically, the buzzer also I think is, I'm sure we've obviously seen it somewhere. And basically, as you can see, it's first thing is that it's connected to ground from basically so that all the current goes up to ground and kind of cycles back again. After that, you see the red wire, which is the VCC for this, or basically the positive channel of the current, and then you can see it's connected to the Arduino via this red wire over here, and basically I've programmed the Arduino so that it plays a certain tune. For example, what I'm playing right now is the Pink Panther tune. After that, we also have this photoresistor, which is kind of right over here. As you can see, this is the photoresistor, and basically, as you can see, I've activated by putting my hand too close. But as you can see, start ringing, and basically the photoresistor, basically it's a resistor. It's the same as the resistor at the back right over there, but then it basically responds to current. Let me turn that off for a moment. Okay, so basically that photoresistor responds to light change. So basically, basically when there's less light basically that's being given, after that it starts to activate when that less light is there, and then it starts basically, as you can see, like one wire is connected, this orange wire, which is like basically connected to the power pin of the Arduino. It's connected to 3 volts. After that, we see another blue wire, which is actually connected to the analog pin of the Arduino. Basically an analog pin. It is a pin on the Arduino that can read values from 0 to 1024, 0 being the minimum value that is given into it, and then 1024 being the highest amount of current that is passing through the wire. So basically using that data, I have built it in a way that it responds to that current. And basically for that, I think that should wrap it up for the things there. And yeah, so basically the next part will be how I've coded the Arduino. Okay, so now let us look at the coding portion of the Arduino. So basically all this code is available publicly at https:/github.com/Mr. Who's a Coder Guy, and then you can find all this code there. So basically, as you can see, at the first couple of lines, I'm basically just defining a bunch of variables. So basically the photo pin is the photoresistor pin, the red pin is the red LEDs pin, the green pin is the green LEDs pin, and then the buzz pin is the buzzers pin. After that, we move on to the setup function, which is basically a function that runs on the Arduino only once, like basically right after it gets power. So we see the size of pins over size of pins of 0. Size of pins, so pins is an array. So size of pins will give the length of the array in bytes. So let's say that's 12 bytes long. After that, if I divide it by size of pins of 0, which means D8, and that's like 4 bytes long, I believe. So it's going to be 12 over 4, which is going to be 3 bytes. And basically, length is the length of the pins array, which, which as you see is 3. So that's what I wanted. After that, you can see I'm looping with a for loop so that I can capture each of the pins and then set them to outputs using the special pin mode function. So basically the Arduino needs to know which are outputs and inputs. So a little bit weird, which had me really confused at first, so I had to spend a long time kind of fixing that. After that, after that is another pin mode, which is the photo pin to an input. So basically, since the photoresistor's pin is actually supposed to be an input rather than an output, right? Because I'm reading from it. After that, we move on to this loop function. Basically, the loop function, this long photo val is equal to analog read photo pin, will basically read the values from the photo pin, and basically the values are going to range from 0 to 1024, 0 being the lowest current, and then 1024 being the highest voltage. After that, as you can see, I'm actually printing it to the serial monitor, which is something that you can access in the Arduino IDE. So then I check if the photo val is less than 1024, and then like if it is less than 1024, which means that I've kind of brought my hand close to it, then basically I've used this function called set color, which will actually this function called set color true, 1, which means that it will turn on the red LED. After that, I played this function called play melody. So basically this is the set color function, as you can see. So basically you see this function called digital write red P high, which means that it will basically give voltage to the red pin, as you can see. High means give voltage, and low means stop the voltage going there. After that, we also have this play melody function. So basically, part of this I've actually copied from a open source GitHub repository, because this is a little bit complicated to write. Well, actually it's not complicated, it's just, anyways. So after this, also basically to play the melody, I have this a whole note of melodies. As you can see, this is the melody, and basically this is the Pink Panther theme. So basically, so the funny thing is, so basically the place where I got these notes from, it was a little bit too long, so I had to kind of, mess around with the tempo and everything. So as you can see, the tempo 120, I had to mess around with it, and then kind of cut out some notes and join some other notes, and then put some other notes in to make it look a little bit better. So that took a long time as well. So then after that, basically in this function, I play the melody, which is timed exactly to 20 seconds. After that, I turn off the red LED by using the set color false, 1 function, and then basically that one also turns on the green LED respectively. After that, I put a delay of 5,000 milliseconds, which means that it will stop everything for 5,000 milliseconds and then leave everything the way it was, which means that it will keep the green LED on for 5 milliseconds. Basically after the 5 millisecond wait, you see this set color true, 0, which means that it will turn off both the LEDs after the 5,000 millisecond wait. And that is pretty much it for the code. So yeah, hope you liked it.